Vanakkam friends, I welcome you all to subscribe my YouTube channel Trinity Cultural Academy to get upcoming videos. Thank you very much for your kind support. The topic today which I am going to deal is soil chemical properties in soil science, that is natural resource management. In soil chemical properties, we are going to deal about 8 properties. I will list out one by one: soil colloids, clay minerals, cation exchange capacity, in short it is called as CEC, soil pH, base saturation percentage, plant nutrients, soil salinity and sodicity. However, in this presentation, I am going to present only 2 chemical properties, namely soil colloids and clay minerals. First one is soil colloids. Fraction of soil containing less than 0.002 mm in size are called as clay particles. What do you mean by soil colloids? Soil particles less than 0.001 mm in size is called as soil colloids. The general properties of soil colloids are furnished here, that are size, surface area, surface charges, adsorption of cations, adsorption of water, cohesion, adhesion, swelling and shrinkage, dispersion and flocculation, Brownian movement and non-permeability. We will see one by one in detail in further slides. Already we have seen that the soil colloids may be organic or inorganic, which are extremely smaller in size of less than 2 micrometers in diameter and can only be seen with the electron microscope. Soil colloids have larger external surface area per unit mass. For example, 1 gram of colloidal clay has 1000 times more external surface area than that of coarse sand. In general, most of soil colloids have negative charges, sometimes positive charges. Negatively charged colloids particles attract and attach to positively charged ions like hydrogen, aluminum, calcium and magnesium. Water molecules are attracted to adsorbed cation and it plays a critical role in physical and chemical properties of colloids. Next important property of soil colloids is cohesion, that is tendency of clay particles to stick together due to attraction of clay particles for water molecules held between them. Next property is adhesion, that means attraction of colloidal particle to another substance when it comes in contact. Next important character of vertisol and black soil is swelling and shrinkage. Examples of soil clay colloids exhibiting their character belongs to smectite group like Montmorillonite. Kaolinite, chlorite or fine-grained micas are not swell and shrink, while vermiculite has intermediate in this character. Next we see about the dispersion and flocculation. What do you mean by flocculation? The particles that when soil colloids lose their negative charges, in which the particles coalesce to form flock or loose aggregates and finally settle them. Reverse process of flocks into individual particles is known as De-flocculation or dispersion. Next property is Brownian movement, in which oscillation of particles due to collision when they are suspended, and at last colloids cannot pass through semi-permeable membrane. Let us now discuss an important aspect, the types of soil colloids. There are 4 types and they are layer silicate clays, iron and aluminum clays, in other words it is called as sesquioxide clays, halophanes, and final type is humus, which is a organic colloid. Let us see one by one. Layer silicate clays, also known as Phyllosilicates. Here Phyllon means leaf, which is leaf-like structure. It is made up of silica, tetrahedron and aluminum octahedron. Second type of soil colloid is iron and aluminum oxide clays. Here most of the silica and aluminum in minerals are dissolved and leached by rainfall. Sometimes it may be due to intensive weathering of minerals. Sesquio oxide, derived from Latin word sesquiu, means one and a half times. That means one and a half times more oxygen than aluminum and iron. It is a mixture of aluminum hydroxide, iron oxide and iron hydroxide and has lower solubility. Examples are gypsite and geothite. Third type is allophane and other amorphous minerals. Allophane is an amorphous to poorly crystalline hydrous aluminum silicate clay mineral commonly found in soils formed from volcanic ash. Has high ion exchange capacity. Next important one is humus, a organic colloid, amorphous in nature, dark brown to black color, in nearly insoluble in water but soluble in dilute acids like sodium hydroxide and potassium hydroxide. It is made up of carbon, hydrogen and oxygen. Friends, let us now discuss the difference between organic, that is humus, and inorganic colloids, that is clay. First we will see the humus. Humus is made up of carbon, hydrogen and oxygen. It is a complex amorphous organic colloid and it is more dynamic, formed and destroyed more rapidly, complex structure not well known. Where the clay is made up of silicon, aluminum and oxygen. It is an inorganic and crystalline colloid. These colloids are clay are stable and relatively stable, and clay have definite and well-known structure. Then we will see the classification of layer silicate clays. In 1:1 type mineral, 1 silica tetrahedral and 1 aluminum octahedral are present. The best example is Kaolinite. In 2:1 type clay, there are 2 silica tetrahedral and 1 aluminum octahedral are present. Two types are, one is expanding and another is non-expanding mineral. The example of expanding type is Montmorillonite and vermiculite. The examples of non-expanding type is mica, specifically fine-grained micas. The examples are muscovite and biotite. Regarding 2:1 type of minerals, the silicate group is represented by chlorite, which is basically iron magnesium silicate with some aluminum. Example of mixed and interstratified layers are chlorite-vermiculite and mica smectite. Example of carbonate minerals are calcite and dolomite, while gypsum is sulfate mineral. Good friends, this slide is also important. Here I have furnished the properties, structure, shape, total surface area, cohesion plasticity and swelling capacity, external surface, internal surface, cation exchange capacity and anion exchange capacity of different the colloids like Montmorillonite, illite and Kaolinite. Please kindly go through this very carefully and read for the examination point of view. Next, friends, we can see one-liners. Particles less than 0.001 mm size possess colloidal properties is called as soil colloids. Soil colloids have a larger external surface area per unit mass. Most of the soil colloids carry a negative charge. Tendency of clay particles to stick together due to attraction of clay particles for water molecules is called as cohesion. Vermiculite is an intermediate in swelling and shrinking. Reverse process of breaking of flocks into individual particles is known as de-flocculation. One-liner continues. Layer silicate clays, also known as Phyllosilicates. Humus is an organic colloid. Prominent 1:1 clay mineral is Kaolinite group. 2:1 type of mineral is Montmorillonite and vermiculite. Major sulfate mineral is gypsum. Good friends, the last part of this presentation is question and answers. The example of non-expanding 2:1 mineral is, the option is C, chlorite. Particles less than 0.001 mm size possess colloidal particles are called as B option, the soil colloids. The basic building blocks of layer silicate clays are, the option D is the correct answer, that is silica tetrahedral and aluminum octahedral. The last question is, example of 1:1 clay minerals is option C, both A and B, that is vermiculite as well as Montmorillonite. My dear friends, if you want PDF and to write online tests, weekly tests, you text at 9894904745 or mail at vanangamudi.tnau@gmail.com. Please kindly subscribe my YouTube channel to get upcoming videos. Thank you very much.